In our final video for this segment here on Introduction to Logarithms, we have to go through some applications, which is another fancy way of me saying word problems, or just really understanding how and why we should care about logarithms in general. And so they do appear all over the place. Certainly in any place where we have an exponential function, we may need to use a logarithm to undo the base of the exponent and get at that exponent. Okay. Other examples where they occur naturally, there's functions of loudness. So when you calculate anything with decibels, like how loud something is, loudness is on a logarithmic scale, as is magnitude of an earthquake, which it might be more commonly known. Um, and this I/O that you see in both of these equations, we call this like the minimum threat or minimum intensity threshold. So minimum intensity threshold. Okay. Um, and this is applied a little bit differently in each of these contexts. So, for example, in loudness, the minimum intensity threshold would be like the minimum loudness of a sound for you to be able to register that there's a sound, or for something to register there's a sound. In terms of an earthquake, it would be like the minimum threshold you have to reach for there to be an earthquake considered, right? Is it, just stomp on the ground and there vibrates a little? Is that the minimum threshold? Or is it like literally the ground has to shake some discernible amount? But anyway, that I/O is specific in each of these contexts. And then lastly, in your chemistry courses, when you're calculating pH is on a log scale. Negative log, and then this H plus in brackets, you may recognize this, maybe not, but this is the did I spell that? Hydronium ion concentration. And so then to calculate the pH, as long as we know the hydronium ion concentration, do the log of that, slap a negative on it, and boom, you have your pH. Speaking of pH, first example is going to be about that. So hydronium ion concentration is, oh, look, okay, so negative log, and then that is our hydronium ion concentration, okay? And then we want to know what the pH is. Okay, that isn't too hard. I could put this in my calculator since I have a log base 10, or I can just save my work or save my energy from reaching for my calculator, taking the cover off, punching it in, which you've probably done by now. I get it. Um, but you could also recognize that the base of the logarithm matches the base of the exponential expression inside. And so we just have negative of negative 8. So this is just 8. Okay. And so I should say the pH is 8. Okay. And again, context situations require context answers, but there you go. That's how you get pH. Next example. Hair dryer operates at 70 times the threshold of hearing. How many decibels? Okay, so this is dealing with that loudness equation. Let's maybe just write that down again. So L of I is equal to 10 log. So L of I is equal to 10 times log of I over IO. Okay, now IO, I want you to think of that as a number. This is fixed. Okay, so then we have 70 times the threshold of hearing. How I represent that is literally write it out mathematically. 70 times the threshold of hearing. So that is the minimum threshold intensity. And so what I need to do in here is say, okay, I'm finding the loudness or the decibel measurement of a sound that is 70 times the threshold of hearing. So 10 log of 70 IO over IO. Okay, those are going to reduce. And so I get 10, oops, that's supposed to be 10 times log of 70. Okay, and that you could certainly punch in a calculator. This is log base 10. Okay, it can't simplify this one because this inside here is not an exponential expression with base 10. But if I go ahead and punch that in my calculator and approximate this, I get about 18.45, and this would have the units of decibels on it. Okay, and so I can say the hair dryer has has about 18.45 decibels. Okay. Strictly speaking, if I was following sig figs, I'd probably say what, 20. Okay, but we'll go with this for now. Okay, if a more precise answer is needed, we'd let you know. But bottom line of all this is logs have practical uses. We can talk about decibels and pH and magnitudes of earthquakes, each of which was calculated using a logarithm in it. Okay, so point is, yay logs, we can do things with logs. There we go. So now this ends the first segment of our introductory piece on logarithms, and we'll get some more practice with them.